Number 16. It says to find g of 2, g of 4, and g of 6 if g of x equals to the integral from -2 to x f of t dt. Now remember, the integral means the antiderivative. And because this is a definite integral, it just means the area under the curve. So I want to find g of 2. That means wherever I see an x at in my function, I'm going to plug in 2. So g of 2 is going to equal to the integral. Let's put that in blue, actually. The integral from -2, because x is 2, that's going to go to +2. And that's going to be of f of t dt. So basically, we want to find the area under the curve between x is -2 and x is +2. And if you notice, this is a circular region right here. This is a half a circle, a semicircle. Let's shade that all in. Okay, let me stop wasting time. Now we should know the area of a circle. The area of a circle, actually I want to write it up here, is A is equal to pi r squared. But this is only half of a circle. This is a semicircle. So the area of a semicircle is going to be pi r squared divided by 2 because it's only half. And what is the radius? We need to know the radius. What is r? Well, the radius is the distance from the center of the circle to any point on the outer regions of the circle. So my radius, let's actually delete that. Where's my undo? Make my pen a little bit thicker in this case so we can see it. But the radius from this point here to that point there to that point there seems to be 2. So my radius is 2. So that means the area for the highlighted part between -2 and +2, that's going to equal to, or rather I can say g of 2 is going to equal to pi. My radius is 2, so that's going to be 2 squared divided by 2. And when you do the math, g of 2 is going to equal to 4 pi over 2. G of 2 is equal to 2 pi. Let's remember this for your exam, if it is on your exam. Okay, let's find the next one. And I want to clear some things up. So let's erase some things. I didn't mean to do that. Actually, you know what? I think I did. All right. It says find g of 4. So g of 4, the x value is 4. So wherever I see an x at, I'm going to plug it into my function as 4. So it's going to be the integral from -2 to +4 of f of t dt. So 4 is right here. I'm going to put a line right here separating it. So that means We want to find the area from -2 to 4. So we're finding this area right here, which we already did. We know this is 2 pi. But then we have to also find this area down here. Let's try to make sure we get this good. We already know the yellow area. We just found it. This is 2 pi. So that means we just have to find the blue triangle. So I'm going to zoom out and I want to rewrite this. We can write this. And remember, I taught you guys how to break this up. Now remember, there's a rule for integrals. And I'm going to go up here. Suppose if we have the integral going from a to b of some function f of x dx. And let's say that there is a number c. Is a number c that is between a and b. Then we can rewrite the integral as the integral from a to b of f of x dx as equal to the integral from a to c of f of x dx plus the integral from c to b f of x dx. We can break that up, and I'm going to show you how I'm going to break it up and why I'm choosing to break it up. Now, you don't have to. If you're very analytical, you can just continue with the problem. I just wasted a minute and a half of your time. But I'm going to break this up as the following. The integral from -2, but I'm going to choose the point here of +2 of f of t dt. And I'm going to add that with the integral from +2 to 4 f of t dt. And we should know what this part is already. This part, we found it in the last question. This is 2 pi. Which means we only have to find this part now. But you knew that already because we don't know what this part is. This is a triangle. The area of a triangle A equals to 1/2 base times height. All right, the base of this triangle, the distance from 2 to 4, that is 2. And this triangle goes down. It goes down until x, well, really until y is +2. So the height of this triangle, h, is -2. So the area of this triangle should be negative because it's below the axis. A equals to 1/2 times 2 for the base times -2 for the height. These two simplify. Oh, what happened here? And the area for my triangle is going to be 2. -2, excuse me. So that means that this part right here is -2. So G of 4 equals to 2 pi minus 2. Last but not least, we need to find g of 6. So let's erase some things. Let's erase this. Let's erase this. But we do know the area of this blue triangle is -2. So I'm going to put that down here. If we're trying to find the area, rather, if we're trying to find g of 6, that's going to equal to the integral from, remember, it is -2 to x. X is 6. -2 to 6 of f of t dt. And I'm going to break that up once again. I'm going to write this as the integral from -2 to 4 f of t dt plus the integral from 4 to 6 f of t dt. And the reason why I'm choosing to do it like that is because we already know that this part is 2 pi minus 2. And we're going to have to now add it with the integral from 4 to 6 of f of t dt. So now let's shade in green. From 4 to 6 is going to be another triangle. This triangle looks about the same area as the blue triangle because the base of this triangle is +2, but the height of this triangle is -2. So to find the area of the green triangle, it is going to be 1/2 times base times height. So I'm going to do it over here. It's going to be 1/2 times the base, which is 2, times the height of that green triangle, which is also 2. These two simplify each other out. So we're left with just -2. Bring down everything else. So the area of the green triangle is -2. So to find g of 6, (2 pi minus 2 plus -2. -2 plus -2 is -4. G of 6 equals to 2 pi minus 4. And that is the answer. All right, guys. Hopefully you enjoyed this video. You liked the content. It made sense to you. Let's zoom out. Yeah, I did number 15 first. Well, number 17 first. I'll catch you in the next one. Take care.